So we have a implicit differentiation problem. So we want to find the slope of the tangent line to this curve. All right. So we're going to differentiate both sides of this. On the left side, we're going to use the quotient rule. Okay, so what I would recommend actually is for each line of this, just pause the video and then try to work it out, and then you can check it here. So the first step is the quotient rule. So it's the denominator times the derivative of the numerator, dy dx, minus the numerator, y, times the derivative of the denominator, derivative of x is 1, and we have -4 times dy dx. Okay, it's in terms of x, right? And then over the denominator squared, and differentiating the right side, we just have 3x squared. Okay. You might ask, maybe, why do we not have a dx over dx? You could put that there, but then dx over dx would just be 1, so we don't write it. All right. Going to multiply out those brackets, and we have a nice simplification here because of a -4 and a +4, so those cancel. Right, -4, +4. So we are left with that. Okay, and basically what we want to do is solve for dy dx. So we're just going to solve this for dy dx. Basic algebra. But you should write it out. Okay. Yeah, let me just say, writing out the algebra is different than watching the algebra. You can watch it and understand, but then when you need to do it, you might not have that muscle memory. So you want to definitely write this stuff out. Okay, so we multiplied by that denominator. Then we add the y and divide by x. And there is our expression for dy dx. And now all we have to do is evaluate it at the point given. And we plug in 1 for x and plug in 4/15 for y. And that's just a calculation. And final answer, 0.28. Okay. So that's implicit differentiation. That is the slope of the tangent. The value of the derivative at any point is equal to the slope of the tangent. That's a good thing to keep in your mind. All right, I hope that was helpful.